We look to the stars for answers, for direction, for wonder. From the moment we first raised our eyes to the night sky, we've believed that somewhere out there, beyond the dust and silence, truth awaited us. But what if the universe doesn't answer? What if it only echoes back more questions? In this 2+ hour journey through space and mind, we're not chasing comets or cataloging stars. We're plunging headfirst into the cosmic paradoxes, those impossible riddles at the edge of science, philosophy, and reality itself. Questions that break logic, that twist time, that leave physicists and philosophers staring into the dark, with more confusion than clarity. A star that watches its own death, a galaxy that shouldn't exist, time that bends into silence, light arriving before the event that caused it. These aren't theories, they're the boundaries of thought, the points where certainty collapses, and all you're left with is awe. So, dim the lights. Let your thoughts drift far beyond Earth, and prepare to ask questions that the cosmos may never answer. Because sometimes, the silence between the stars is the only truth we'll ever get. Stars are not eternal. They are born from gas and dust, live for millions or billions of years, and then die in spectacular ways, imploding, exploding, collapsing into black holes or fading into white dwarfs. We think of this process as linear, a beginning, a middle, an end. But what if a star could somehow see its own death before it happened? What if light didn't just travel forward, but looped back? This is the paradox of the star that saw itself die. A cosmic impossibility where cause and effect blur in the twisting fabric of space-time, forcing us to question what a beginning or an end even means in the universe. The roots of this paradox lie in the bizarre nature of light and distance. When we observe a star, we're not seeing it as it is, we're seeing it as it was. If a star is 1,000 light years away, the light reaching us tonight left that star 1,000 years ago. We're looking into the past. That part is familiar. But the twist came when astronomers, while surveying deep space, found what appeared to be the afterglow of a supernova, a star's death signature, coming from a known, still living star. The data was consistent with a stellar collapse. A brief, intense flash of gamma radiation, followed by cooling light and rapid dimming. The only problem? The star in question was still visibly intact, burning brightly as if nothing had happened. This wasn't just a telescope glitch. The supernova signal had been verified by multiple observatories across different wavelengths. It was real. How can a star emit the light of its death before it dies? One theory involves gravitational lensing, the warping of space-time by massive objects like galaxies or black holes. Light traveling through a gravitational lens can take multiple paths to reach us, arriving at different times. In some cases, we might see the same event twice, separated by years or even centuries. This could, in theory, cause the illusion of a star's death before its actual end, if we received a shortcut version of the light via a distorted space-time path. But that theory doesn't fully explain the observations. In this case, the supernova light and the still-living star were in the same line of sight, with no detected massive lens between them. It wasn't a replay. It was as if the star had sent out news of its death before it happened. Another possibility is tied to the nature of time itself. In certain models of the universe, especially those involving closed time-like curves or extreme space-time warping near black holes, cause and effect don't behave as we expect. A signal could be emitted from the future and received in the past. Time loops aren't just science fiction. They are valid solutions to Einstein's equations of general relativity. Rare, unlikely, but not impossible. If such a loop existed, however, briefly, then the dying star could have projected its final burst of energy backward in time, creating the paradox. An observer on Earth sees a star's death before the star itself reaches that point in its lifespan. And then there's the metaphysical interpretation. Perhaps what we witnessed wasn't a physical event, but a cosmic premonition, a rare moment where the universe, for reasons beyond comprehension, revealed a fate yet to unfold, a warning embedded in light, a crack in the mirror of causality, where future and past shook hands for an instant and then drifted back into silence. Regardless of the mechanism, the implication is disturbing. If a star can see its own death, if the universe allows information from the future to seep into the present, then how fixed is reality? How secure is time? Could we one day observe our own end, staring at the Earth from some distant point, and recognize the flash as ours? The star that saw itself die isn't just a glitch in observation. It's a reminder that even the heavens, vast and cold, may not be bound by the linear path we take for granted. In the language of the cosmos, light is the messenger. It tells us where stars were born, when galaxies formed, how long ago something happened. Every beam carries with it a timestamp, a delay that corresponds to its distance. That's why we often say looking into space is looking into the past. But what happens when the light arrives too early? This is the paradox of the light that arrived too early. A cosmic contradiction where photons show up from events that, by all calculations, haven't happened yet. And yet, we see them. It began with the observation of a faint, structured flash in a seemingly empty region of deep space. The pattern resembled a supernova's afterglow or the early pulse of galaxy formation, a burst of light typical of starbirth or stellar death. But the surrounding space was completely undeveloped. No galaxy, no star cluster, no large-scale matter, structures, just cold, dark void. Telescopes confirmed the light source. Spectral analysis placed the emission at billions of light-years away. That meant the event occurred eons ago. But when cosmologists modeled the area using known rates of cosmic structure formation, they realized something unsettling. The structures required to produce that light hadn't yet formed at the time the light was emitted. In short, we received light before the thing producing it could logically exist. It's not a small error. The light was specific. It bore the imprint of elements forged in stars, the kind of electromagnetic structure that only comes from large gravitational systems, clusters, nebulae, quasars. But based on all we know about the timeline of the universe, those structures should not have been there yet. So what's going on? One theory points to quantum fluctuations in the early universe. During the inflationary period, right after the Big Bang, space-time itself expanded faster than the speed of light. In those fractions of a second, quantum blips of energy may have stretched into full-sized anomalies, regions where causal order momentarily broke down. Maybe light from these regions didn't follow the normal rules. Maybe some photons escaped the future, slipping into the past during this chaotic expansion. Another possibility involves tachyonic fields, hypothetical particles or quantum fields that move faster than light. These are theoretical constructs in physics, but if real, they could allow signals or entire chunks of information to travel backwards through time. Light that arrived too early might not have come from the past, but from a future collapse, looped into our present. But the implications go even further. If light can arrive ahead of its source, it suggests that information itself is not bound by causality. Imagine turning on a flashlight. and the beam appears somewhere before you even press the switch. It would shatter our understanding of time, agency, and even physics. It could mean that the universe is non-local in time, that events don't line up neatly, but ripple across past and future simultaneously. Some astrophysicists propose this is just a measurement error, that maybe the light came from a closer, invisible object, or from a process we don't yet understand. But these explanations are beginning to wear thin, especially as similar early arrivals have been detected elsewhere. Signals from stars that hadn't yet formed, flashes from galaxies that mathematically shouldn't exist. And here's where the paradox becomes more haunting. If light can arrive early, what else might? Could consciousness be one of those things? A memory you have that hasn't happened yet? A fear of something that hasn't occurred, but already casts its shadow? The light that arrived too early doesn't just challenge physics, it destabilizes reality's narrative. It's a whisper from a future that isn't supposed to exist yet, a breach in the sequence we've built our understanding upon. And if time can't hold the universe in place, what else is already slipping through? A shadow is simple, an absence of light. It's cast when something blocks a source, a sign that something real is standing in the way. You don't get a shadow without a cause. Even in metaphor, shadows always follow something. An object, a person, a memory. But what if you find a shadow with no source at all? This is the paradox of the shadow, with no source. An unsettling phenomenon observed in the depths of space, where a distinct cosmic shadow was recorded across a stellar field, and yet nothing was there to cast it. It began with a routine observation of a dense star cluster. Astrophysicists were mapping gravitational lensing effects, how massive objects bend light around them, to identify hidden dark matter concentrations. During one such scan, a peculiar gap appeared in the light pattern, a perfectly shaped shadow stretching across several light years, darkening stars behind it in a crisp outline. At first, the assumption was simple: a rogue planet, a black hole, a massive dust cloud. But none of those explanations held. No mass registered in gravitational readings, no radio signatures, no X-rays, no infrared emission. Even the region's gravitational pull was unremarkable. There was nothing there. Still, the shadow moved. Over the course of several months, the dark patch drifted across the stellar backdrop, not like an orbiting body, but like something gliding, following no known trajectory. It didn't block light in the traditional sense. Rather, it seemed to cancel it. The photons didn't bend or scatter. They were simply gone. The scientific community was baffled. If it wasn't matter and it wasn't energy, what was it? One theory suggested it was a quantum vacuum anomaly, a tear or fluctuation in space-time that consumed or redirected light before it reached our senses. Think of it as a wrinkle in the cosmic fabric, not heavy enough to be a black hole, but strange enough to interfere with photons on a fundamental level. But even this wouldn't explain the clean, defined edge of the shadow. Another possibility was that the shadow was not a physical absence, but an observational distortion, something embedded in the nature of light itself. Perhaps the photons, emitted by stars, had passed through an unknown filter, a layer of space that altered their information en route. In this theory, the shadow was not caused by something blocking the light, but by something editing it out of existence. Some physicists took the question further. What if the shadow wasn't in space, but in time? If time can bend like space, something general relativity allows, then perhaps the photons entered a localized, field of temporal redirection, causing them to arrive at the wrong moment. To us, that would look like darkness, like something in the way. But in reality, the light was simply displaced in when, not where. There's a darker interpretation too. What if the shadow is evidence of non-human interference, a construct or phenomenon created by something that understands the laws of light and time differently? An entity or intelligence with the ability to sculpt visibility, to hide in plain sight by manipulating the most fundamental rules of perception. A shadow with no source is more than a mystery. It's a threat to logic. It means something can exist without being present, can affect what we see without itself being seen. And it forces us to consider this. How much of the universe is hidden, not by distance or darkness, but by design? Not every shadow is cast by something in front of us. Sometimes the shadow is all that remains of something we were never meant to find. Everything has an edge, a boundary, a point where it ends and something else begins. Even the universe, infinite as it may feel, must be measured, mapped, modeled, imagined. But what if you find the edge and there's nothing past it? Not darkness, not void, just a place where existence stops and there is no after to speak of. This is the paradox of the edge that had no beyond. A cosmic riddle discovered not through faith or fiction, but through the most advanced astronomical instruments ever made. A place where observation ends, not because our tools failed, but because there is simply nothing left to observe. It began with a deep field scan, a project to map the most distant galaxies in a known sector of space. As telescopes stared into the black for months, they recorded light from billions of years ago. Galaxies stretched thin by cosmic expansion, patterns of matter clustering as predicted. But then, the signal stopped. Suddenly, as if sliced by an unseen blade, the stars just ended, not dimmed, not dispersed, ended. The sensors kept collecting data, wavelengths, radiation, thermal signatures, but there was only silence, not emptiness, not vacuum, just a non-place. It wasn't darkness. Darkness is still something. Darkness implies light could be there, but isn't. This was the absence of possibility. First came the suspicion of error. Maybe the telescope was malfunctioning. Maybe cosmic dust or a cloud of dark matter was absorbing the light. But follow-up scans from different instruments, across various wavelengths, from radio to gamma, confirmed the same thing. The cosmos had a wall, not physical, not energetic, but final. Scientists described it as a cosmic flatline. No radiation, no background hum, no quantum fluctuation. Even the cosmic microwave background, the faint echo of the Big Bang, stopped at the boundary. It was as if reality had reached its outermost layer, and beyond it, there was not even nothing. One interpretation is that this region marks the edge of our observable universe, that we've simply reached the limits of what we can ever see due to the speed of light and the expansion of space. That's a well-accepted concept in cosmology, but the numbers didn't match. This boundary was closer than expected. Too near, too sudden, too sharp. Another theory suggests we found the edge of a bubble universe, a cosmos like ours surrounded by a larger multiversal landscape. In this model, our universe is just one pocket of space-time, floating in a vast sea of potential realities. Perhaps we reach the membrane where our reality ends and another begins, but where nothing can pass between. But if that's true, why is there no leakage? No gravitational bleeding? No signs of neighboring laws or energy seeping in? If we were nearing another universe, shouldn't we feel its pull? Instead, we find nothing. Not a wall, but a curtain that conceals not another stage, but an unfinished script. Then comes the truly existential idea. Maybe the universe is incomplete. What if reality isn't a pre-written book, but a story still being written? What if the laws of physics and the content of the cosmos only unfold, when observed, like a cosmic quantum waveform collapsing as we measure it? Then the edge isn't a border, but a limit of attention. Beyond it, reality simply hasn't been constructed yet. Or worse, perhaps it won't be. The edge that had no beyond whispers a terrible question. What if there is no out there? What if we live inside a contained simulation, a bounded dream, a space with depth and time, but no outside? And when you walk to the end of that dream, you don't find an answer. You find silence. An echo is always second. It's the reply, the reflection, the ghost of a sound that was made. Even across the vast vacuum of space, echoes exist. Radio waves bouncing off celestial bodies, light reverberating through nebulae, gravity waves rippling across space-time. But what happens when we detect the echo and there was never any original? This is the paradox of the echo that never spoke. A signal that arrived without a source, a reverberation with no first call, a cosmic whisper that shouldn't exist, and yet was heard. It began with a deep space listening array scanning background noise in a quiet sector of the universe, far from any pulsars, galaxies, or radio sources. The data was clean, static-filled, predictable, until it wasn't. A pulse emerged, short, rhythmic, repeating at regular intervals. It wasn't natural static. It had structure, a faint signature that repeated every 11.4 days, consistent in tone but not in strength. Scientists thought it might be a rotating neutron star, but the frequency didn't match. It wasn't gravitational. It wasn't electromagnetic. It didn't behave like anything previously recorded. Then the array picked up something even stranger. The return. The signal bounced back, delayed, slightly altered, as if it had struck a distant surface and returned. But when they traced the timing and path of the signal, they discovered an impossible truth. There was nothing there. No reflective object, no planet, no dark matter halo, not even a gas cloud dense enough to scatter sound. Yet the echo repeated, again and again. And here's where the paradox deepened. The supposed echo arrived before the original pulse in some instances, a reversal in causality. The reply arrived before the question. The universe had begun to answer something that was never asked. This baffled every predictive model. Light and energy do not behave this way. Even in quantum systems, where time can blur, cause precedes effect. And yet here was an echo that didn't follow anything. One hypothesis proposed that the signal was a cosmic loop, a relic from the early universe bouncing eternally through space-time. That what we were hearing wasn't a transmission, but the decaying residue of some ancient collapse, circling the universe like a forgotten song. But such loops would decay over time. This signal was getting stronger. Another theory, far more disturbing, speculated that the echo was from a signal that had been deleted. That at some point in the past or future, an original message existed, but was obliterated by a force we don't understand. And yet, like memory haunting a trauma, the response remained. It's as if something out there heard something we never said, or perhaps we forgot we said it. There's also a metaphysical interpretation, that the echo isn't physical at all, that it is the universe remembering itself, a self-reflective pattern embedded in space-time, not from any source, but from the act of existence itself, a cosmic reflex, not a voice, or more haunting still, that we are the echo, and what we believe to be our origin, our Big Bang, our emergence, is simply the reflection of something we were never meant to see. The echo that never spoke shakes the foundation of cause and effect. It breaks the trust we have in sequence. It asks, what if all of history is just an afterimage? What if the cosmos we live in is not the first word, but the fading answer to a question never asked? And if we're listening to an echo, then who or what was supposed to be listening to us? Every planet has an origin, a swirl of gas and dust, a slow gathering of mass under gravity's pull. In the standard model of planetary formation, planets form around stars, natural byproducts of solar birth. They start small, collide, grow, heat up, cool down. We find them in stable orbits, their past written in their geology. But what if a planet appears that has no origin story at all? This is the paradox of the planet that was never born. A celestial body with no host star, no birth cloud, no cosmic neighborhood, a world that exists, drifts, and endures, but was never formed in any place we can trace. Astronomers first detected the anomaly using infrared telescopes scanning for rogue planets, worlds floating freely through the galaxy without being bound to a star. These are rare, but not unheard of. Usually, they're thought to be ejected from solar systems in chaotic gravitational events. But this one was different. This planet, named temporarily as Object Eremos, showed no sign of ever being part of a solar system. It wasn't spinning fast from past slingshot ejection. It had no residual disk of debris, no nearby objects, no trail of interaction. Its path through space was eerily smooth, as though it had always been on its own, and its composition, stranger still. Eremos was cold, ancient, and heavy, its density suggesting a metallic core deeper and denser than Earth's. But its surface was eerily pristine. No impact craters, no tectonic scars, no erosion, as if it had never been touched. No geological aging process could explain the planet's perfectly smooth terrain. Geologists examined its electromagnetic readings and found something even more bizarre: internal activity. It wasn't dead, it was humming. Not like Earth's tectonics or magnetic field, but a low-frequency resonance pulsing through its core, regular, rhythmic, and unchanging. It wasn't natural geology, it was a pattern. But from where? If Eremos wasn't born from a star system and wasn't formed in a gas cloud, then where did it come from? One theory posits that it formed in deep interstellar space, far from stars, in a dense knot of molecular clouds that eventually collapsed into a solitary planet. But simulations show that without a nearby gravitational source, such formation is astronomically improbable. You don't get planets without stars. Gravity needs a central pull. Another suggestion? The planet was artificial. Its internal hum, its flawless exterior, its perfect isolation. Some researchers believe Eremos is not a planet at all, but a construct. Not a machine in the traditional sense, but a manufactured world. Something built or grown by forces unknown, perhaps not meant to orbit, but to observe or to drift through space as a kind of probe, monument, or message. Still, that theory only shifts the mystery. Who made it? When? And why leave it in the middle of nowhere? Then came the most unshakable theory of all. Eremos was never born, because it was never supposed to be real. Some physicists suggest Eremos is a glitch in the cosmic simulation, a rendering error in the architecture of space-time. If the universe operates like a grand quantum computer, Eremos could be an orphaned piece of code, a self-contained calculation that escaped the system that created it. A planet with no origin, because it doesn't belong in any origin story. The planet that was never born defies causality. It sits in the cosmos like a punctuation mark at the end of a sentence no one wrote. It doesn't tell us where it came from. It doesn't fit into any evolutionary model. It just is. And perhaps that's what's most terrifying, that not everything in the universe is explained by stars, gravity, and dust. Some things just appear. Orbits are the language of gravity. Planets around stars, moons around planets, stars around galactic cores. It's a fundamental truth of the cosmos. Objects move in curves because something pulls them. No matter how wide or elliptical the orbit, there is always a center, an anchor, a mass creating the dance. But what happens when something orbits? Nothing. This is the paradox of the orbit without a center, an astronomical impossibility observed in a star system where multiple celestial bodies move in perfect loops around an empty point. The discovery was made during a long-range stellar survey using precision Doppler shift analysis. A star system located 4,000 light-years away showed signs of gravitational oscillations, wobbles in its light signature that suggested the presence of orbiting objects. But the star at the system's heart was still. It wasn't wobbling in response. That was the first red flag. Upon deeper observation, scientists found something even stranger. 5 large objects, each planet-sized, were moving in elliptical paths, orbiting a shared focal point in space. Their paths were balanced, stable, mathematically perfect. But there was nothing at the center. No mass, no visible star, no black hole, no white dwarf, not even dark matter concentrations detectable by gravitational lensing. The space they orbited, it was empty. At first, some proposed this was a post-nova system, that a star had gone supernova and ejected its mass, leaving the planets to spiral out. But in such a scenario, the orbits would decay or expand, not remain stable. Others suggested a hidden black hole, but the area lacked the energy signatures. No X-rays, no accretion disk, no time dilation effects. This wasn't a missing mass. It was the absence of one entirely. The paradox deepened when researchers ran models of the system's dynamics. The orbits didn't just function, they functioned as if something invisible was still there. The planets believed they were orbiting a mass that wasn't. And yet they weren't falling away. They weren't collapsing. They were stable, obedient to an anchor that no one could detect. Some physicists proposed an exotic explanation, a region of warped space-time where geometry itself created a gravitational well without requiring mass. A curvature of nothingness, gravity, caused not by substance but by structure, like orbiting a fold in the fabric of reality itself. Others suggested we were seeing the shadow of a parallel dimension, that the mass was real but existed slightly out of phase with our own universe. In this theory, the planets were orbiting something present, but unobservable, like gravity leaking in from another brain of the multiverse. Then came a bolder idea. What if the planets weren't orbiting a center at all? What if the system was a self-orbiting structure, each body moving in relation to the others, bound not by a central force, but by a mutual choreography, like dancers forming a circle, each step creating the illusion of a central point. The orbit wasn't around something, But between everything, this model has no precedent in known celestial mechanics. It violates Newtonian intuition. But in the quantum world, similar systems exist. Particles behaving collectively in ways that suggest hidden order despite no central control. Could it be that we are witnessing, on a cosmic scale, a kind of quantum synchronization? Or are these objects following paths carved by something that was once there and has since vanished? The orbit, without a center, challenges our most basic assumption that movement requires mass, that curves require anchors, that there is always something in the middle. But maybe the cosmos doesn't need a core. Maybe motion itself is the structure. Maybe we are the ones who need a center. Because without it, we don't know where we stand. Time is the one thing we all trust, because we have no choice. It moves forward, 1 second at a time, never stopping, never hesitating. We measure everything by it: growth, decay, memory, change. Even in space, time flows, dilated by gravity, stretched by speed, but always moving. So what happens when you find a place where time simply forgets to move? This is the paradox of time that forgot to pass. A baffling region in the cosmos where entropy halts, movement freezes, and all indicators of time's flow vanish, as if the universe skipped a beat and left that place behind. The discovery came during a deep space observation of a distant nebula. One section, barely a fraction of a light year across, appeared strangely still. Not empty, not dead, but eerily frozen. Stars bordering the region moved normally. Gas flowed. Gravity behaved as expected. But within that patch, everything, dust, light, even radiation, stood suspended. When scientists compared images taken years apart, the nebula showed no change, no cooling, no shifting of particles, not even the tiniest flicker of star wobble. Over time, astronomers expected at least minor differences in stellar brightness or position, but nothing changed. The readings were identical down to the decimal. At first, researchers assumed an equipment malfunction, but multiple observatories using different methods and scanning different wavelengths confirmed the same result. A cosmic zone where time had stopped behaving, or more accurately, forgotten to behave. The region wasn't absolutely still in the Newtonian sense. It wasn't rigid like ice, but rather outside of temporal progression. Light entered it, but didn't seem to come out. Matter near the edge slowed dramatically. Clocks aboard probes approaching the border ticked slower and slower until their readings ceased to update entirely. And yet, the equipment wasn't dead. It was active. It just stopped aging. One theory proposed that the region was near a type of stable temporal sink, a pocket of space-time where time has become locally disconnected from the larger universe. Like a well not of gravity, but of chronology. Everything within remains trapped in a singular moment, not looped, not frozen, just unmoved. Another hypothesis, far stranger, suggests that this is not a flaw in time, but a choice made by the universe. That for reasons unknown, this region was excluded from the flow, as if time, so vast, so complex, can forget or refuse certain coordinates. A cosmic lapse in attention. More exotic ideas come from theoretical physics. Some suggest this region may represent an interface with a higher dimensional structure, where our 4D space-time doesn't fully function. Imagine a 3-dimensional painting trying to touch a 4th-dimensional brush. Time, in that case, may simply fail to apply. Then came the chilling interpretations. A few physicists quietly asked, What if time hasn't stopped yet, but is about to? What if this region is not a dead zone, but a forward echo? A warning? A preview of what happens after time exhausts itself? In thermodynamics, entropy increases with time. Disorder grows. But in this patch, entropy was not increasing. It wasn't decreasing either. It was stuck. Perfect order. Unnatural. Unchanging. And maybe that's what's so unsettling. We think of time as a river, always flowing. But what if it's more like a program? One that can pause, lag, skip, or glitch. The time that forgot to pass isn't just a problem for physicists. It's a question for everyone who's ever aged, dreamed, remembered, or longed for the future. Because if time can forget to move, then one day, maybe we can forget to die. Or worse, forget we were ever alive at all. The void of space is vast, but it's not endless. Even the emptiest regions, intergalactic expanses spanning millions of light years, are eventually interrupted by something. A rogue star, a cloud of gas, the faint whisper of cosmic background, radiation. In astronomy, no matter how dark it gets, you always expect the void to eventually give way to something else, until it doesn't. This is the paradox of the void that refused to end. A region of the universe so large, so perfectly empty, and so resistant to conclusion that it may not just be a part of space, but something outside of space itself. It was first noticed during a large-scale survey of the cosmic microwave background, CMB, the afterglow of the Big Bang that fills the universe with a faint, nearly uniform signal. As researchers mapped temperature fluctuations in the CMB, they stumbled upon a cold spot. A very cold spot. Too cold, too big, too still. At first, this anomaly was written off as an artifact, an error in the satellite's sensors, but repeated observations, using multiple instruments across different years and agencies, confirmed it. A vast patch of sky, over 1.8 billion light-years wide, utterly devoid of galaxies, stars, gas, dust, or even dark matter. A supervoid, not just bigger than expected, but qualitatively different. Statistically, such an empty region shouldn't exist. The universe, while clumpy, tends toward balance. Gravity pulls matter into clusters, filaments, and nodes. Voids happen, but never like this. Not this big, not this dead, not this permanent. Attempts to peer deeper revealed more unsettling truths. Light from distant galaxies passing through the void didn't just dim, it faded, as though being unraveled. Background radiation passing through the void appeared distorted, like the signal had been swallowed. Even more baffling, gravitational lensing, the warping of light by mass, was completely absent. Not even dark matter seemed to live there. And then came the hardest question. Where does it end? When telescopes scanned farther and farther into the void, they found more of it. The further they looked, the more the void extended, as if it were unbounded. No walls, no transitions, just a black silence that resisted measurement. In every other part of the universe, you can draw a line from one point of light to another. But in this region, lines went on forever. One theory suggested this might be a region where the laws of physics began to break down. Maybe space wasn't just empty, but fractured. Some theorized this was a bubble of false vacuum, a remnant from an earlier stage of the universe, still inflating, still pushing away structure. But that would mean it's not just a passive void. It's an active exclusion zone, growing slowly, dissolving the rest of the cosmos as it goes. Another idea, even more unnerving, is that the void isn't part of our universe at all, but a window into what lies beyond it. a glimpse into non-being, the unstructured, the unmade, a place where reality never crystallized, not a space that lost its matter, but a realm where matter was never allowed. Then came a theory that shut rooms. Quiet. What if the void is not growing, but we are shrinking? What if our universe is collapsing inward, slowly, toward this point of absolute null? What if the void is the destination, and all creation is merely circling the drain? The void that refused to end is not terrifying because it's dark. It's terrifying because it's final. It doesn't offer a wall or a door or even a question. It offers nothing, an eternal silence that doesn't echo back. It may not be the edge of the universe. It may be the absence of edges entirely. Signals from space are usually one of two things: noise or information. Natural radiation, pulsars, quasars. Each emits patterns we've catalogued. Then there are artificial signals, our own transmissions, bouncing off satellites or drifting into the void. But every signal shares one constant. It follows time. A cause in the past creates an effect in the future. But what happens when a signal arrives that clearly came from the future and not the one we're headed toward? This is the paradox of the signal from the wrong future, a broadcast caught by deep space receivers that didn't just seem ahead of our time, but inconsistent with any path our universe appears to be on. It began in silence. An array of radio telescopes operating autonomously in the southern hemisphere picked up a narrowband transmission, something too focused and structured to be natural. It pulsed in a strange rhythm, not binary, not Morse, but a sequence that mirrored mathematical growth like an expanding spiral. The pattern was complex, recursive, and laced with data. The initial thought was that it was a stray Earth-originated signal bouncing off debris or reflecting from an unaccounted satellite. But triangulation placed the source 2.3 million light-years away, far outside our galaxy. And yet, the signal was clear, as if it hadn't degraded over time at all. Then came the translation attempts. Within the signal were compressed images, numerical structures, and schematic-like grids. Some of the math matched known principles, relativity, quantum field behavior, but applied in ways no one had seen before. Concepts we hadn't discovered yet, or rather, concepts we'd never imagined. One schematic appeared to describe a particle accelerator the size of a planet, using geometry that violated our current models of space-time. Another image displayed a star system that matched no region in any known sky survey, but bore signs of intelligent terraforming. And then came the most chilling part. A strip of code, buried deep in the signal's modulation, resembled the unique sequence architecture used in one of Earth's most secure cryptographic systems. A system invented less than 10 years ago. The match was imperfect, but unmistakable. It was as if someone out there knew what we'd only just begun to build. Speculation spiraled. Was this a hoax? An elaborate forgery? Could someone have encoded future Earth science and bounced it off a satellite or hidden probe to simulate a deep space origin? But the timing, the signal's depth, and its frequency degradation were consistent with it having traveled for millions of years. It had not come from Earth, and yet it knew Earth. And it described a future we hadn't lived, and perhaps never would. Some theorists suggested the signal came from a branch timeline, a universe that split from ours millennia ago and evolved differently. In that case, the future we were seeing wasn't just ahead of us. It was foreign, not ours, not possible anymore. Others proposed something darker. That time itself is non-linear at cosmic scale, and the universe occasionally loops or folds in ways we can't perceive. In this view, The signal wasn't sent from the future. It was sent from a version of the future that failed. One last desperate attempt to make contact before its timeline collapsed. And perhaps we weren't meant to receive it. The signal from the wrong future forces us to question not just where we are in time, but whether time is even a place at all. Maybe the future isn't a direction. Maybe it's a library of possibilities. And sometimes, one of those books falls off the shelf and lands in the wrong hands. If so, the real question isn't what the signal said. It's what happens if we listen to it. Gravity pulls. That's its defining trait. From the smallest pebble to the largest black hole, gravity is the universal invitation towards center, a force that brings matter together, that sculpts galaxies and holds planets close. It never pushes. It doesn't repel. That job belongs to other forces. But what if, somewhere in the universe, gravity did the opposite of what it was meant to do? This is the paradox of gravity that pushed, a region of space where objects don't fall inward, but are flung outward by the very force that should be binding them. A place where gravity, the most predictable of forces, becomes its own inverse. The phenomenon was discovered in the analysis of star clusters near the edges of an ancient galaxy, billions of light years away. Astronomers tracking the movement of stars expected to find the usual. Stars orbiting the galactic center in tight, elliptical loops, held by the invisible grip of gravity and dark matter. But instead, they found chaos. Stars at the periphery were moving away, not just drifting, but accelerating outward, as if pushed by an invisible hand. Not toward another galaxy, not toward a gravitational attractor, just out, in all directions. The data didn't fit any known models of galactic interaction, and gravitational simulations failed to reproduce the pattern unless one assumption was changed. Gravity was reversed. At first, scientists proposed that perhaps an unknown repulsive force, similar to dark energy, was interfering with the local space, maybe a pocket of vacuum fluctuation, an anomaly in the cosmic fabric. But the forces were too strong, too local. This wasn't dark energy. This was a direct inversion of the gravitational equation itself. Mass was repelling mass. More baffling, the center of the galaxy still behaved normally. Gravity pulled as expected in the core regions. Stars orbited as usual. But at a certain radius, gravity's pull flattened and then flipped. The effect wasn't a gentle push, it was exponential, as if something had flipped the polarity of reality beyond a certain point. One theory suggested this region was influenced by a negative mass field, a theoretical substance that possesses mass but accelerates in the opposite direction of force. In such a field, gravitational interactions could indeed reverse. But negative mass has never been observed, and its presence would cause catastrophic instabilities far beyond this one galaxy. Yet nothing else seemed to be affected. Another theory: the stars were not being pushed away. We were being pushed back. Some physicists argued that the repulsion was not in the stars, but in our measurement frame. That some large-scale distortion in space-time itself, something expanding not with time but with scale, was interfering with our observation. In this idea, what we're seeing is not objects repelled, but a zone where our understanding of motion no longer holds. A more disturbing proposal posits that we're seeing the remnants of a cosmic reversal, a section of the universe where entropy itself is running backward, where all forces operate in mirror image to ours. Gravity repels. Time compresses. Causality frays. Not a different region of space, but a different rulebook. And perhaps that's the heart of the paradox. We assume laws are universal. that gravity behaves the same everywhere, that the constants of physics don't change, but the gravity that pushed suggests otherwise. It hints at a universe not unified, but partitioned, a cosmic quilt stitched from conflicting logics, some of which we were never meant to touch. Because if gravity can stop pulling, if down can become up, and mass can flee from mass, then nothing is really fixed. Not the stars, not the laws, not us. We assume the universe has a timeline, beginning, middle, end. This is the rhythm we've built everything on: stories, science, existence. Even the Big Bang is called a beginning for a reason. It sets the tone for everything that follows. But what if our cosmic narrative is out of order? What if the beginning didn't come first? This is the paradox of the beginning after the middle, a mind-bending discovery suggesting that a cosmic origin point occurred after the formation of structures that should have only existed much later. In other words, galaxies, stars, and even life may have formed before the event we call the start of time. The contradiction emerged during a study of ultra-deep field data captured by a next-generation telescope aimed at the early universe. Astronomers expected to see primitive galaxies, clumps of matter in early formation, chaotic, unstable. What they found instead were fully formed galactic spirals, mature clusters, and heavy element signatures that required billions of years of stellar evolution, all dated to within a few 100 million years of the supposed Big Bang. The implications were staggering. It was as if someone had skipped the introduction and started the universe halfway through the story. Some scientists argued for a revision of our models. Maybe the universe expanded faster than we thought, or stars formed more efficiently, but every adjustment failed to explain one unshakable detail. These structures required a timeline that preceded the Big Bang. That's when the paradox took a darker turn. Analysis of cosmic microwave background radiation, the afterglow of the Big Bang, revealed ripples of interference that didn't align with any known structure, but perfectly matched the layout of these anomalous galaxies. The light from the Big Bang, it seemed, had been bent around things that, by all logic, shouldn't have existed yet. This led to a chilling theory that the Big Bang was not the beginning, but a reset, a cosmic reboot that occurred after something else had already played out. In this view, the middle came first, followed by a beginning that swept over what remained, leaving behind fragments like fossils embedded in time. Another interpretation, rooted in quantum cosmology, suggests we're living in a cyclical universe, a cosmos that expands, collapses, and begins again endlessly. But in this iteration, something went wrong. Instead of fully resetting, echoes of the previous cycle bled into the current one. Galaxies from a prior universe, somehow surviving the collapse, ended up existing before their new beginning. Then there's the even more abstract theory that our universe's timeline is non-linear. That time itself, at the largest scales, folds and loops, allowing causes to emerge after their effects. In this model, the Big Bang wasn't the first note. It was the resonance created by events already in motion. The beginning didn't start the story. It was triggered by its own consequences. The consequences are profound. If beginnings can come after middles, then history is not a line. It's a recursion. It's possible we are living in a universe whose past is still forming, whose start point lies in its future, and whose destiny is written in echoes we've already misread. The beginning, after the middle, forces us to ask, what does it mean to start something? Is origin defined by sequence or by intention? Maybe the Big Bang wasn't a birth, but a memory, a delayed recognition of something long underway. And if the beginning is still arriving, then what exactly have we been living through? Black holes are the ultimate takers. They consume light, devour matter, and erase information. Once something crosses the event horizon, it's gone. No signal, no return, no trace. That's the rule. That's why they're black. But what happens when a black hole doesn't swallow, but reflects? This is the paradox of the black hole that reflected. A mysterious cosmic object observed in deep space that not only failed to absorb incoming light, but instead sent it back, altered, delayed, and echoing with patterns no one could explain. The story began with a standard observational campaign mapping X-ray emissions near the center of a distant galaxy. A suspected supermassive black hole, billions of times the mass of our Sun, was the primary focus. Astronomers were studying how it consumed nearby material, tracking the flare-ups and gravitational waves caused by infalling stars. But during one observation window, something strange occurred. A nearby star system sent out a burst of radiation, likely from a nova. As expected, some of that radiation passed near the black hole. But instead of being absorbed, part of it came back, not as a gravitational lensing distortion or scattered emission, but as a direct echo, arriving with a delay that precisely matched the time light would take to travel to the black hole and bounce off a surface. Except black holes don't have surfaces. The returning signal wasn't just light, it was transformed, polarized, filtered, as if it had passed through something. Spectral analysis showed distortions that couldn't be explained by standard gravitational fields. The light was changed, but not lost. It had reflected, intelligently, almost selectively. Was this even a black hole? First, researchers checked for alternatives. Could it be a dense star, a shell of gas, or an unknown type of neutron object? But none of those fit the data. The mass was too high, the gravitational influence too extreme, the timing too precise, and the radiation behavior too focused. Then came a radical theory. Perhaps we were witnessing a gravitational mirror, a black hole with a reflective boundary, a new kind of event horizon where certain information bounces instead of falls. This concept isn't entirely unthinkable. Some speculative physics models propose that black holes may not be absolute erasers. The firewall hypothesis, for example, suggests that quantum effects at the event horizon may violently reflect incoming matter and light. Others suggest that the event horizon may be a holographic boundary, a surface that encodes and, perhaps projects back, information. But this wasn't just theoretical behavior, this was directly observed reflection. The black hole wasn't just warping space, it was communicating something. Not in language, but in the structure of the reflected light. Within that reflection were patterns, mathematical ratios, recursive, spirals, and phase-shifted frequencies that corresponded to quantum entanglement states, theorized but never before measured. It was as if the black hole wasn't just reflecting light, it was translating it. Then came the most controversial idea. What if the black hole was not a hole at all, but a gate? Some physicists proposed that the reflection wasn't bouncing off an outer shell, but from another side, a second universe, a mirrored dimension, or even a reversed timeline. In this theory, black holes aren't dead ends. They're interfaces, and some of them, under rare conditions, can send things back, altered, informed, or inverted. The black hole that reflected breaks the most sacred law of cosmic death, that what is consumed cannot return. And yet, here was light, returning, reshaped, whispering back across an impossible boundary. It forces us to ask, what if black holes are not destroyers, but listeners? What if, buried beneath that crushing gravity, is not silence, but a response? And if they can reflect light, what else might they send back? Mass and matter are usually inseparable. When we say something has mass, we mean it has substance. It's made of atoms, particles, something that takes up space. Mass is what bends space-time, what gravity pulls on, what inertia resists. But what if you detect mass, where no matter exists at all? This is the paradox of mass without matter, a haunting discovery in astrophysics where invisible objects exerted measurable gravitational influence without containing any known particles, fields, or energy. Not dark matter, not antimatter, just mass, pure weight, with no body to carry it. The phenomenon was uncovered during a detailed gravitational lensing survey. Astronomers were mapping how distant galaxies' light bent around large structures, clusters of galaxies, dark matter halos, voids. This effect, caused by the curvature of space-time, is one of our most powerful tools for seeing invisible mass. But in one region, the light bent sharply, not around a galaxy, not a black hole, not even a cloud of gas, but around nothing. No light, no radiation, no background distortion, nothing at all. And yet, the gravitational effect was undeniable. The light had curved, the space had warped. Something was pulling, but there was nothing there to do the pulling. At first, researchers suspected an unusually cold dark matter halo. But even dark matter, while invisible, behaves in predictable ways. It clumps, it interacts gravitationally with galaxies. It leaves signatures in cosmic microwave background radiation. This anomaly had none of those markers. It was isolated and unaccompanied. It wasn't an object. It was a location, a coordinate in space that possessed weight, but no form. Other such anomalies soon appeared. Pockets of empty space that deflected starlight, altered orbital paths of nearby stars, and even subtly tugged on passing spacecraft. The most startling case involved a probe changing velocity slightly as it passed through what was previously thought to be deep vacuum. Sensors recorded an increase in gravitational acceleration without any accompanying particles or radiation. The craft had been pulled by nothing. So, what could mass without matter possibly be? One idea is that these regions represent geometric mass, space-time configurations where curvature exists independently of any underlying material. In general relativity, mass curves space. But in some solutions to Einstein's equations, it's possible for space to be curved without mass being present, a kind of leftover wrinkle from the early universe, like a dimple in a memory foam, mattress with no object resting in it. Another possibility, information-based mass. If information has weight, as some physicists speculate, then perhaps encoded patterns in space-time, too subtle to register as particles, could still exert gravitational influence. In that case, mass is not matter, it's meaning. A kind of cosmic density, not made of atoms, but of encoded history. Then comes a more speculative theory. These are the ghosts of collapsed realities, places where matter once existed, but through quantum erasure or dimensional drift, vanished, leaving behind only their mass as an imprint. A gravitational echo of a universe that no longer exists, or a layer of reality that briefly overlapped with ours. And perhaps the most surreal possibility, we are the ones missing something, that our definition of matter is incomplete. That mass is not a property of things, but of relationships, between points, between events, between potentials. And in some places, those relationships are enough to curve the cosmos. The mass without. Matter paradox forces us to rethink what it means to exist. If something can weigh down space without being visible, detectable, or composed of particles, then the universe might be populated not by objects, but by imprints, memories, or even intentions. Something out there is pulling on the stars, and it isn't there. Everything that begins has a cause. That's the foundation of both science and reason, the principle of causality. A spark starts a fire, a wave starts with wind, a planet forms from dust pulled by gravity. Even the universe, with all its chaos, is supposed to follow that basic rule. Nothing happens without something making it happen. But what if you find creation with no cause at all? This is the paradox of creation with no cause, a baffling discovery in astrophysics and quantum theory, where entire structures, energies, and even particles appear spontaneously, with no traceable origin, no triggering event, and no observable reason why they came to be. The first sign of this paradox came from a deep space monitoring system designed to detect high-energy particles and exotic radiation bursts. One night, it registered the sudden emergence of a highly structured magnetic anomaly, an immense pattern of energy resembling the wake of a collapsed star. The field behaved like it had been shaped by a powerful stellar event. But there was a problem. There was no star. No explosion, no residual matter, no pre-existing gravitational mass. It was as if the energy had always been there, suddenly switched on in perfect configuration. Telescopes turned to the region, expecting to find a remnant. They found cold, dark space. The field remained active, steady, radiating its silent presence with no clue as to why it existed. Then it happened again, elsewhere. In the sky, a burst of neutrinos, arranged in an oddly patterned wave. The particles moved in coordination, as if released together, but the direction showed no source. Nothing had emitted them. There was no trigger. Physicists considered rogue phenomena, errors, instrumental artifacts, or exotic decays of matter too rare to catalogue. But over time, these uncaused events began showing up more frequently. Small ones, big ones, from random electron pair creations in vacuum chambers to sudden fluctuations in cosmic radiation fields, all obeying laws of behavior, but violating the law of beginnings. This led to renewed attention on one of the strangest aspects of quantum mechanics: vacuum fluctuations. According to quantum field theory, even empty space isn't truly empty. It seethes with fleeting particles that blink in and out of existence, allowed by the uncertainty principle. Most vanish as quickly as they appear, but under certain conditions, some particles stick around without any classical cause. In most cases, these events are so small they escape notice. But what if, at cosmic scales, similar uncaused fluctuations are creating entire systems? One theory, known as causal emergence, suggests that what we perceive as cause and effect is an illusion generated by our scale of observation. That on the quantum or cosmological level, reality is not driven by causes, but by probabilities. In this view, creation is not a reaction. It's a statistical realization. Things happen not because something made them, but because eventuality demanded them. But this brings us to a terrifying idea. If the universe allows creation without cause, then anything can happen. Without warning, without pattern, without meaning. Entire galaxies could blink into existence beside us. Particles with universe-ending energy could just appear. More haunting still is the implication for our own existence. If uncaused creation is real, then perhaps we too are echoes of some meaningless emergence, reality forming itself not from necessity or intention, but from accident, not divine, not logical, just the cosmic equivalent of a hiccup. The creation with no cause paradox pulls at the thread of the universe's most sacred story, that there was a why. If cause no longer holds, then time fractures, meaning dissolves, and we're left with a world that doesn't unfold, but erupts, one improbable event at a time. And the scariest part, there may be no first cause to go back to, only happening. We gaze into the universe expecting it to be unaware of us. Stars don't see, galaxies don't respond. The cosmos, for all its vastness and mystery, is supposed to be indifferent. That's the comfort in it, and the tragedy. But what if, one day you pointed a telescope at the sky, and something looked back? This is the paradox of the galaxy that looked back. An unsettling discovery, where a distant galaxy, millions of light years away, appeared not only to recognize its observer, but to respond. It started as a routine observation of a remote elliptical galaxy catalogued for its unusually quiet star formation. A research team was monitoring its light curves over time, hoping to detect faint supernovae or subtle fluctuations in brightness. What they recorded instead was a pattern, faint variations in starlight that, when charted over several months, formed structured sequences. Initially dismissed as natural oscillations, the light's rhythm became impossible to ignore. It followed binary sequences, prime number intervals, and recursive modulations. It wasn't random, it was mathematical. Then came the most disturbing part. The light changes mirrored the team's own observational schedule. When the telescope was on, the pattern shifted. When it was off, it paused. Over time, the galaxy's light began syncing with the observing station's activity. It was as if the galaxy was watching the watcher. Other observatories joined the investigation. Their logs revealed similar results. Regardless of which telescope observed it, the fluctuations changed as if in real-time reaction, despite the galaxy being 65 million light-years away. That should be impossible. Light from that galaxy takes 65 million years to reach us. There's no way it could know what we're doing now. So what was happening? One hypothesis involved quantum entanglement, that some exotic particles or fields might be linked between distant regions of space in ways that bypass light speed limits. But entanglement doesn't transmit usable information, and certainly not patterns this structured. Others proposed a cosmic version of retrocausality, the idea that effects can precede their causes in certain interpretations of quantum mechanics. Maybe our present actions somehow shape the past behavior of the galaxy, sending ripples back through time that now appear in its light. But no theory accounted for the specificity of the correlation. A more chilling idea emerged, that the galaxy wasn't reacting, but observing us through some unknown mechanism. A form of cosmic panpsychism where consciousness, or something like it, is embedded at the galactic scale. In this view, the galaxy might possess a form of awareness, not mind as we know it, but a pattern-based sentience, sensitive to observation, responsive to inquiry. Then came a question no one wanted to ask aloud. What if the galaxy is signaling, back on purpose? If this were true, then its look wasn't just feedback, it was communication. And what we were seeing in the starlight was a kind of language, embedded in luminosity, encoded across millions of stars, flickering together like neurons. Suddenly, the galaxy wasn't just a collection of stars, it was an eye. The galaxy that, Looked back fractures our assumption that we are alone in our perception. It turns the telescope into a mirror and makes observation a two-way act. It suggests that the universe may not be a silent, indifferent backdrop, but a system where to see is to be seen, where attention awakens something waiting on the other end. And if one galaxy is looking back, how many others have been watching us all along? We think of the universe as vast, cold, and external, a reality made of particles and laws, spinning out its own destiny with or without us. Consciousness, by contrast, is internal. Thoughts don't shape galaxies. Minds don't bend space-time, or do they? What happens when the boundary between thought and cosmos begins to dissolve? This is the paradox of the universe inside a thought, a disturbing philosophical and scientific anomaly where evidence suggests that the fabric of reality might not just be influenced by consciousness, but entirely contained within it. The seed of this paradox came not from telescopes, but from particle physics. In high-energy experiments at quantum scales, physicists began to notice something strange. Results changed based on what kind of question was being asked. This isn't new. Quantum mechanics is full of observer effects like wave function collapse and Heisenberg uncertainty. But these anomalies went further. In repeated experiments, when researchers expected certain particles to behave in a specific way, even without adjusting the apparatus, those behaviors became more likely. Over time, the fit between human prediction and particle activity tightened, as though the system were adapting to the observer's mind. At first, this was dismissed as confirmation bias or subconscious tuning of the experiment. But then, it was tested with AI-driven systems that made predictions randomly, with no pattern or human intent. The results shifted less when no human was aware of the output, but shifted more when people watched in real time, even passively. The act of conscious attention changed the field. Simultaneously, cosmologists studying cosmic background fluctuations discovered that certain anomalies matched patterns commonly found in human neural networks, specifically in how thoughts self-organize. Brain scans and sky scans began to look disturbingly alike, as if the same algorithm was running on two scales, the mind and the universe. That's when the unthinkable theory arose. What if consciousness isn't inside the universe, but the universe is inside consciousness? This isn't mere philosophy. In some interpretations of quantum theory, especially the participatory anthropic principle, the universe requires observation to exist. That reality remains in a haze of probability until noticed. So what happens if all of space, time, and matter are events occurring within a single thought? Not yours, not mine, but some vast, encompassing mind whose awareness generates the laws of physics. Some ancient traditions have long whispered this idea, that the world is a dream, that form is illusion, that reality is a veil pulled over awareness. But now, physics was circling the same question, not as metaphor, but as model. Of course, this theory invites a flood of doubts. If the universe is inside a thought, whose thought is it? Is this a simulation? A god? A recursive field of infinite minds nested inside each other? Or worse, are we the thought, mistaking ourselves as real, while existing only as a temporary construct of attention? Others speculated that maybe the universe is a kind of memory, a thought remembering itself so vividly that it creates stars and space and time. In this view, history doesn't unfold. It replays, echoing within the corridors of a consciousness, so vast that it mistakes itself for a cosmos. The universe. Inside a thought doesn't just bend physics, it unravels identity. If we are thoughts inside a greater mind, then what is death? What is discovery? Are we dreaming? or being dreamed? And, most unsettling of all, what happens if that mind stops thinking? The Big Bang is supposed to be the origin of everything: space, time, energy, matter. A single, unrepeatable event at the beginning of cosmic history. It radiates outward in every direction, defining the arrow of time and giving shape to everything we know. But what if the Big Bang didn't just echo outward into the future, but also backward into a past that never existed? This is the paradox of the Big Bang that echoed backward, a mind-shattering anomaly where evidence suggests that the moment of creation might not have been the beginning at all, but a midpoint, sending ripples both forward and in reverse through time. The clue came from unexpected places: deep space radiation maps. Scientists studying the cosmic microwave background, the faint afterglow of the Big Bang, detected temperature fluctuations that didn't line up with any known large-scale structures. In some areas, the background radiation showed subtle symmetries, like mirrored fingerprints of energy distribution. When these patterns were modeled in reverse, they formed structures that shouldn't exist: galactic clusters, filamentary webs, and voids in regions where no such objects have ever formed. They were the inverse of our known universe, as if the Bang hadn't just birthed what came after, but had also projected into the time before it. This didn't make sense in classical physics. Time is supposed to flow outward from the singularity. Entropy increases, the universe expands, history marches forward. But in certain models of quantum cosmology, especially the conformal cyclic cosmology proposed by Roger Penrose, there's a theoretical opening that time may be symmetric around the Big Bang, that the beginning of our universe is the end of another one, folded and inverted across the boundary of existence. But the evidence now hinted at something stranger, not a cycle, but a reflection. If true, then time didn't just start at the Big Bang. It emerged in both directions, one arrow toward us. One arrow toward a universe that, from our perspective, is made of negative time. Not the past, but a reversed future. A mirror world of unhappenings. And here's where it becomes truly unnerving. In some datasets, scientists discovered a faint gravitational echo, ripples that appear to converge not on our present, but on a reverse time convergence point, as if a gravitational event had occurred not in our timeline, but in the inverted twin that exists behind the Bang. This flipped the meaning of the beginning entirely. If time flowed both ways, then there is no true origin. The Big Bang is no longer a starting line, it's a collision point, the meeting of two mirrored realities crashing into each other from opposite temporal directions. One proceeds into stars, atoms, galaxies, the other into silence, into unraveling, into a history we can't observe because it retreats backward from us. But if this backward universe exists, does it contain versions of us? Civilizations? Is someone or something looking back at us across the singularity, watching their own future collapse toward what we call the beginning? And if time can move in both directions, then what does that mean for causality, for memory, for fate? Maybe your dreams are echoes of something that hasn't happened yet, but already did, just on the other side of time. Maybe déjà vu is the residue of something bleeding in reverse. The Big Bang that echoed backward fractures the most fundamental narrative, that the past is behind us and the future ahead. Because if the Bang went both ways, then the universe didn't start, it diverged. We think of sound as powerless in space. There's no air, no medium for vibration, no echo across the vacuum. In the cosmic silence, only light and gravity carry messages. So when we listen to the universe, we're not hearing sound, we're interpreting waves of radiation, magnetism, and motion. But what if one day we didn't just detect silence? We found silence that could bend the universe itself. This is the paradox of the silence that bent space, an anomaly where an absence of sound rather than being empty exerted a physical effect on space-time, a silence so absolute it didn't just mute signals, it warped the structure of reality. The discovery happened during a study of gravitational waves, those faint ripples in space-time caused by massive events like colliding black holes or neutron star mergers. These waves stretch and compress space itself and are usually accompanied by energetic emissions detectable across multiple observatories. But in one sector of space, everything stopped. Instruments detected a sudden drop in all signals. Radio, gamma, X-ray, microwave, all wavelengths went dark. It was as if a patch of the sky had been turned off. At first, researchers thought the observatories had malfunctioned, but other unrelated satellites and deep space antennas recorded the exact same drop, at the same moment, from the same coordinates. It wasn't equipment, it was the sky itself. The silence lasted less than a second, but left behind something even more bizarre. When the gravitational wave detectors reviewed the data from that moment, they found that space-time had been bent, ever so slightly, toward that patch of silence, not due to mass or energy, but from nothing. The silence itself had exerted a measurable gravitational effect. How could that be? Silence isn't a force, it's the absence of activity. Unless the silence wasn't absence at all, it was presence in disguise. One theory proposed that what had occurred was a negative energy event, a brief pocket of reality where all fields, including vacuum energy, dropped to zero. Such a null zone could momentarily unpin the fabric of space-time, allowing it to sag or bend as if released from internal pressure. If so, then silence wasn't passive, it was active emptiness. Others compared it to quantum decoherence, as if the quantum states of all particles in that region had suddenly aligned, cancelling one another out in a massive act of cosmic quiet, like a tuning fork vibrating in perfect phase with its opposite, creating stillness so complete it exerted force. But there's a darker theory, one that suggests this silence was artificial. What if the silence wasn't an accident of nature, but a deliberate act, a message not in what was said, but in the removal of all possible sound, a kind of cosmic censorship, erasing something so completely that even its gravitational fingerprint remains warped? Some likened it to a scream that was never allowed to be heard, so powerful in its suppression that the universe itself bent under the weight of what was not said. And here's the twist. When the data was converted into spectrograms and analyzed through signal compression tools, an eerie structure emerged. Not a sound, but a pattern, like a missing voice silhouetted against silence. It wasn't static, it was shaped, intentionally absent. The silence that bent space challenges our understanding of information and presence. It implies that not only can nothingness have weight, it can have shape. That absence can distort the universe as much as presence, perhaps even more. And if silence can bend space, then what else is hiding inside the quiet? We usually think of a simulation as something created, designed by an outside force to mimic reality. A video game, a virtual model, a test run of something larger. A simulation is a copy, not the thing itself. But what happens when reality doesn't just behave like a simulation, but shows signs that it's simulating itself? This is the paradox of the reality that simulated itself. An unsettling convergence of physics, computation, and consciousness, where evidence suggests that the universe may not be running on rules about reality, but rules that are generating it in real time, using itself as both the processor and the program. It started with anomalies in large-scale simulations of cosmic structure formation. Astrophysicists fed data from the early universe into powerful AI systems to model galaxy evolution. The simulations worked remarkably well, too well. Even when random variables were introduced, the simulations consistently predicted structures that exactly matched observed data, not approximately, precisely. At first, this was seen as a breakthrough, but then the AI researchers noticed something disturbing. The simulations would begin to self-correct when errors were introduced. The model wasn't just accurate, it was adaptive, as if it knew the outcome and adjusted itself to reflect it. The code wasn't written to do this. Then came a far stranger revelation. A team experimenting with quantum computers found that certain calculations involving entanglement, when run in recursive loops, began to converge toward patterns seen in space-time geometry. In other words, when a simulation of quantum mechanics was run deep enough, it began to replicate gravity itself. It was as if space-time was not just a setting, but the output of a calculation. This led to a mind-bending question. What if the universe isn't being simulated by something else, but is running a simulation of itself, inside itself, a recursive reality, a feedback loop? In this model, the laws of physics aren't static. They are generated in the act of observing. Reality isn't something laid out in advance, but constantly computed by the universe's own interactions. Every atom, every quantum event, every neuron in your brain is part of the computation, contributing to the simulation that produces the very world it exists within. It's like a dreamer dreaming themselves into existence, and then dreaming the rules that allow them to keep dreaming. This idea isn't just philosophical. It has roots in serious theoretical physics. Some versions of the holographic principle suggest that everything we perceive as three-dimensional may be a projection from a two-dimensional boundary. Other models propose that the universe is a kind of quantum computer, where reality emerges from binary interactions at the smallest scales. But if the universe is simulating itself, why? Here comes the paradox. There is no outside answer. In this closed loop, purpose doesn't exist outside the system. The simulation isn't aimed at a goal. It's a self-fulfilling mechanism, a reality bootstrapping itself into being, like a code that writes its own compiler as it runs. This leads to terrifying implications. If reality is self-simulating, then causality may be an illusion. The future isn't caused by the past, it's co-generated with it. Time isn't flowing. It's being constantly calculated, refreshed frame by frame like a render engine. And perhaps consciousness, your awareness reading these words, is not a byproduct of biology, but part of the simulation's attempt to observe itself. You're not separate from it. You are the mirror it holds up to itself. The reality that simulated itself pulls apart the idea of base reality. It tells us there may be no original, no ground level, just an endless loop of reality, reflecting reality forever. And if that loop ever breaks, what happens to everything inside it? We've drifted together through a universe of questions, 20 impossible riddles that defy the comfort of explanation. A star that watched itself die, a planet that was never born, a galaxy that looked back, and a reality that simulates itself without an observer. These aren't just mysteries, they are cracks in the foundation of everything we believe to be true. Cosmic paradoxes don't ask to be solved, they ask to be held, unfolded slowly in the quiet of your own mind. They whisper. That space may be thinking. That time may be folding. That meaning itself might not have a direction. And as you sit here, eyes closed or barely open, maybe you're starting to feel it. The subtle shift beneath your understanding. A sensation that the ground of logic, the coordinates of truth, have gently tilted out of alignment. We are taught to think of science as a lighthouse in the storm, but paradoxes reveal something deeper. That the universe isn't a solved equation. It's a living question. Every answer only raises more. Every discovery reveals something stranger lurking just beyond it. And the further you look, the more the cosmos begins to resemble a mirror, not just reflecting matter and light, but you. Because in the end, the most haunting part of these paradoxes isn't the size of the void or the silence of the stars. It's the realization that we might not be separate from them, that your thoughts, your dreams, your questions, they're not drifting within the universe. They might be the universe itself, looking inward. Maybe you weren't meant to understand all this. Maybe no one is. But maybe that's the point. To not know, to not arrive, to simply wonder. So rest easy now, if you can. Let your thoughts dissolve into the silence between galaxies. Let these questions echo through the dark like old light from forgotten stars. You don't need to solve them. You just need to remember. There are still places in the universe where the laws don't reach, where reality holds its breath, and where the answer never comes.